Hello everyone! In this video I will show you how to implement binomial heap in C++. Let's begin with theoretical aspect of binomial heap. Binomial heap is a collection of binomial trees. The definition of binomial tree is the following. B0 is a single node and bk consists of two trees bk-1 which are connected in such a way that root of a first tree is leftmost child on the root of the second tree. This definition is a recursive definition and we can see it at the current illustration. Here we can see example of binomial trees from a tree with depth 0 to tree of depth 4. Now let's explore some of binomial trees properties. bk tree has exactly 2 to the power of k nodes. Height of a tree equals k. At the depth of I there is k choose I binomial coefficient nodes. Degree of the root is equal k and its ith children counting from leftmost is a root of bi subtree. The conclusion of these properties is that maximum degree of a node in nth element tree is equal to logarithm of n. At the current illustration, we can see binomial heap consisting of trees b0, b2 and b3. There are 13 nodes in the heap. Furthermore, binomial trees are ordered by increasing values of the degree or number of elements. The key in a node is not less than the key of its parent. At the illustration B, we see representation of a heap as a linked list. Every node consists of parent field, key, degree of a node, pointer to right sibling and pointer to leftmost child. Degree of a node is equal to number of children of this node. The order of roots degree in the heap is strictly increasing. Sibling of a root is pointing to the root of the next tree. Now let's see basic operation on binomial heap. First see binomial heap union procedure. As we see at the current illustration, first step is to merge these two heaps. The output of merge is now binomial heap that contains trees in non-decreasing order. In this new heap we can have trees with same degree. Here it's node with key 12 and 18, and also trees with root 7 and 3, which degree is equal to 1. Next step is to link trees with same degree. Here we link 12 and 8 keys. The outcome is that we have 3 trees with same degree equal 1. Then we link trees with root 7 and 3 to form new tree with degree 2 and root 3. Next we link 2 trees with same degree 2 and root 3 and 15. After this step we have all trees with different degree, which are 1, 3 and 4. Another procedure is binomial heap insert, which insert a node into the heap. Here we simply create new heap with this single node and call union on these two heaps. The next function is binomial heap extract minimum, which returns and removes node with the lowest key. We begin by finding the tree with the lowest key of its root. We do this by moving through the list of roots until the right sibling is null. We remove the node with minimum key and create new heap consisting of children of removed root in opposite order. It means that first tree in a heap will be rightmost sibling of a child of removed root. Next will be node one before this last, and so on until the last is tree with the root of leftmost child of removed root. This new heap will contain trees with increasing degree. Finally, we union these two heaps and return the output heap. We can see this procedure on the current illustration. First we remove root with key 1. Then we create second heap from children of 1 in opposite order. First is tree with node 25, then 12, after it 16, and last 6. Next we call union on these heaps. Another procedure is decrease key of a node. Here we change key of a node to new key which is smaller than key of a node, and then swap this node with its parent if its parent key is greater. The next and last procedure is deleting a node. To do this, we call decrease key with key equal to minus infinity, which can be lowest representable integer value. After that, we call extract minimum on a tree. For the purpose of this video, I created simple program that demonstrate basic operations on binomial heap. It's C++ Winapi application written in Visual Studio. Source code is in the video description. Let's run the application. It reads numbers from numbers.txt file. Numbers must be distinct. On the left of the window we have our binomial heap. On the top right of the window we have 4 buttons that perform heap operations. Let's insert few nodes and see the output heap. Insert node 20, 21, 22 and 23. Now let's extract minimum. It's a node with key 6. Next, we decrease key Finally, let's delete a node from the heap. You can try to play with this app. Now let's take a look at the code. We have binomial heap insert, which creates new list with single element node. Then we call binomial heap union. If one of the heap is empty, we return second heap. Next, in while loop, we merge these two heaps, iterating each heap's roots and the age variable, which is a list of pointers to node, consists of merge trees. Then we perform adjusting so that none two trees in the heap has same degree. Here we call binomial link if two neighbors trees has same degree. At the end, we return heap age. Let's see definition of a node. It has pointer to parent node, key, integer degree, pointer to left child, and pointer to right sibling. Now let's see extract minimum function. First, in main loop we find pointer to root with minimum value. Then we remove this root from the heap adjusting pointers of the root before it in the list. We must remember removed root in a variable. If removed node doesn't have children, we end procedure. However, if removed node has children, we iterate over them and change sibling nodes to opposite and then make a heap from them. Last step is to union main heap with children of removed node. The current display shows main loop in decreasing heap procedure. We move the node up, swapping with parent if necessary. Finally, deleting node is implemented from decrease key and then extract min. That's all, thank you for watching.